So there are multiple ways to solve systems. We've done substitution and elimination. Now we're going to solve them by graphing, and then we're going to learn another way that's really nice later. So let's suppose that I had two linear equations, y equals 2x minus 3, and y equals negative 5/3 x plus 4. One of the easiest ways to find the answer is just to graph them. So go ahead and graph both equations. So 2x minus 3 and negative 5/3 x plus 4. So now we just need to find the intersection. Where do you suppose that button is hidden? Second calc, the same place we find all the other calculations. And we want to find the intersection, so go to number 5. And it's going to ask you 3 questions. And the nice thing about this is, as long as you only have 2 graphs, you can't really screw this up. So notice at the top it says y1 equals 2x minus 3. If you push up or down, you switch from one function to the next. If you push left and right, then you change the x values. So it says, tell me the first curve you want me to show you. Well, just hit enter because there are only 2 curves. Find the second curve. If you have 3 or more graphs, you need to be a little bit more careful and make sure that you pick the correct graphs. But as long as there's only 2, just push enter, enter. Now it wants a guess. Well, there's only one intersection because these are straight lines. Because they're straight lines, you can hit enter anywhere and it will find it. So the intersection is 1.9 and 0.81. Okay? That's pretty nice. All right, what if we had something like y equals x plus 10 and y equals 4x? So we go in x plus 10 and 4x. We graph them. And the intersection is above the screen. Well, the calculator doesn't care. So do second calc intersect and hit enter 3 times. Enter, enter, enter. And it found it for us. Okay. All right. What if I had x plus 10 and we'll say 1 over 4x? So 1/4 x now the answer's off the screen. When I do second calc intersect, enter, 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 it gives me an error. No sign change. Which is doing something that you don't realize what that means, but it's basically saying there's no answer. How come it didn't care if it was above, but it's off to the side? The calculator cares. It's lazy. Your calculator only thinks the function is defined on the domain listed in your window. So as long as your x values are wide enough, it will find the intersection. If your x values are not wide enough, then you need to extend your window. So if I go into window, what do I need to change in order to see the answer? The x min, and let's change it to, I don't know, 20. Negative 1,000 would work, but might be a little bit overkill. So second calc intersect, enter, 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 and there's the intersection. So as long as your domain is wide enough, it will find the answer even if it's off the screen. If your domain is not wide enough, it's going to give you an error. Okay? Well, what if I had x plus 10 and x? What do you know about those two graphs? And I'm going to push zoom standard to get back to my standard window. They're parallel, and if you do second calc intersect, it's going to give you no sign change again. So just because it says no sign change, that doesn't mean they're parallel, because it will give you no sign change if the answer is not in the domain. So you need to look back at the equation and say, oh yeah, they have the same slope. So they will be parallel. All right, what if I graph x plus 10 and x plus 10? What is the answer here? Infinite solutions, but you have to be careful. I want you to do second calc intersect. Intersect. And Devin got 0 and 10, and I got negative 0.21 and 9.7. Who's right? Both of us. So you have to be careful here. Wherever your cursor is when you push guess, you're just asking the calculator, find the intersection closest to this set of numbers. Well, because it's the same line, anywhere that cursor exists will be the answer. So just because it gives you an intersection doesn't mean that's the answer, because no matter what intersection you look for, you're going to find it. So this one's infinite solutions. Okay? All right. What if we had 2x minus 3y equals 6 and 5x plus 7y equals 3? How would I graph these to find where they intersect? You need to solve for y. So I'm going to subtract 2x. So 6 minus 2x, and then, so once I get this alone, what's my next step? Divide by negative 3. And my recommendation is you don't simplify anything. You just put the top in parentheses. You could put it in slope-intercept form, but your calculator doesn't care. As long as you type in an equation that's equivalent to slope-intercept, it's going to graph it. So for the next one, I'm going to subtract 5x and then divide 7. So 3 minus 5x, put that in parentheses, and divide by 7. So the first one, 6 minus 2x over negative 3. Second one is 3 minus 5x divided by 7. So second calc, intersect, enter, enter, enter. My intersection would be 1.75 and negative 0.82. So you have a really short worksheet with 4 problems that are linear, and then you have a set that's nonlinear. So the only thing difficult about the nonlinear problems is you might have more than one answer. For instance, if we have a parabola and a line, then it's possible for those to intersect more than once. So if that's the system, they never touch. That system has one intersection, and this system has 2 intersections. So one example of this would be the functions x squared minus 9. So if I type in x squared minus 9, oops, and the function x, these are going to intersect twice. So the only trick is when you do your guess needs to be close to the intersection. So second calc intersect, and I just go over to my first guess, enter, enter, enter. There's the first answer. Second calc intersect, and I go over to the other intersection, and I do the same thing. Enter, 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 and there's my second intersection. So some of the problems in your assignment today might have 4 answers or no answers or 5 answers. It depends on the problem. So do both of those. Hand in the short worksheet before you leave, and the next one's due tomorrow. Good luck.